Hello everyone. In this lesson, I am going to show you how to estimate the population proportion. Previously, we had talked about how to estimate the population mean in two scenarios. Now we're talking about how to estimate the population proportion. So this is section 8.3. When you are talking about estimating the population proportion, you are thinking about answering questions like these that I have here. What proportion of American voters will vote Republican in the fall? Well, not this fall. Actually, that will be this fall actually. Yeah, this fall. Because the American elections are coming up, right? So what proportion will vote, right? That would be estimating the population proportion. So it's a fraction, right? Or if you're talking about market share, how much of the Canadian telecommunications market is controlled by Shaw Communications, right? So that's proportion. You will express that as a percentage. Or what percentage of SAIT students speak French as a first language? That's another proportion scenario. So if you're going to estimate population proportions, you are answering questions that sound like these. So to do that, we are going to approach it in a very similar way to what we did previously. We need a point estimate, and we add and subtract an error estimate. Okay, so confidence intervals are always done in that way, right? If you're going to estimate the population mean or population proportion. So we're going to be doing like that right here. Okay, point estimate plus or minus error estimate. The point estimate for estimating the population proportion is the sample proportion p hat. So we'll calculate p hat, which is the sample proportion, and we'll use that to compute or calculate our interval estimate for the population proportion. The error estimate is calculated as shown, is z sub alpha over 2 multiplied by the square root of p hat times q hat divided by n. Z sub alpha over 2 is your critical value, like we did when we're estimating the population mean when sigma is known. So the Z tables that we used in chapter 6 and chapter 7, that's what we're going to be using here to find Z. So that will give us confidence interval. The range is as shown, right? But don't be afraid of that. What I'm saying is just this. Okay, so p hat plus or minus z sub alpha over 2 multiplied by square root of p q over n, p hat q hat. Where, of course, q hat is 1 minus p hat. Okay, p hat is the sample proportion, and then we'll get our interval estimate in that way. So, for instance, PricewaterhouseCoopers surveyed 210 chief executives of fast-growing small companies. Only 51% of these executives had a management succession plan in place. A spokesperson for Coopers & Lybrand said that many companies do not worry about management succession unless it is an immediate problem. However, the unexpected exit of a corporate leader can disrupt and make a company lose focus for long enough to cause it to lose its momentum. Use the data given to compute a 92% confidence interval to estimate the proportion of all fast-growing companies that have a management succession plan. So to do this, to answer this question, all we want to do here is to create an interval estimate of companies that have a management succession plan. Okay, given that in a random sample that was chosen, only 51%. Okay, the sample proportion is 51%. So the information we have will help us to create a confidence interval as shown. We need to find the point estimate, and we need to figure out what the error estimate is. Our point estimate we're given is 51%, which is 0.51, and Q hat, which is the complement of that, is going to be 49% or 0.49. Sample size is 210, and so our interval of confidence is 0.92, and that means our error is 8%, 0.08, half of which is 0.04, which is 4%. So what we're trying to figure out there is our Z value, our critical value. The picture we're thinking about is as shown. In your table of values, you only get that area that's shaded in blue, 0.4600. And so in your table of values for Z table, you're going to look for the area that's closest to 0.4600. Okay, and we talked about how to use your Z tables previously, so I will not be doing that here. So if you look in your table of values, you will see that that Z value that you're looking for is 1.75, which you can now use in your confidence interval formula to give you an interval that looks like this. Your error is 0.06. So your confidence interval is 0.51 plus or minus 0.06, which will give you a range of between 45% and 57%. So that means that 92% confidence interval indicates that between 45% and 57% of companies have a management succession plan in place. Let's do another example. A clothing company produces men's jeans. The jeans are made and sold with either a regular cut or boot cut. In an effort to estimate the proportion of the men's jeans market in Kingston, Ontario, that consists of bootcut jeans, the analyst takes a random sample of 212 jean sales from the company's 2 Kingston retail outlets. Only 34 of the sales were for bootcut jeans. Construct a 90% confidence interval to estimate the proportion of the population in Kingston who purchase bootcut jeans. Okay, so what proportion of the people who buy bootcut jeans or who buy jeans purchase bootcut? That's what this question is talking about. Again, we are creating an interval estimate for the proportion. So the formula for that is as shown. The sample proportion, p hat, we are told that it's 34 out of 212, so which is 0.16. Q hat, the complement of that will be 0.84, and so the confidence level 1 minus alpha is 90%, with alpha being 10%. So the area in each of the tails is going to be 5%. The picture we're looking at is this one as shown. So we're looking for an area of 45% between the mean and our critical value Z sub alpha over 2, 0.4500. So you're going to look for what's closest to 0.4500 if you can't find the exact area in your Z tables. But I think in this case we can. Actually, we can't. Okay, it's going to be in the middle between two values. So you will see that it's 1.645. Right, it's between 1.64 and 1.65. So that's our Z value. We will now use that in our confidence interval formula, and we'll substitute all the known values as shown to give us 0.16 plus or minus 0.04. That's our error range. So if you subtract 0.04 and you add 0.04 to 0.16, you will get a range of 12% to 20%. That is the 90% confidence interval to estimate the population proportion of those jeans buyers who buy bootcut jeans in Kingston, Ontario. I hope that's clear to you. So what you should do now is try an example by yourself. Okay, it's a small example. And like we've done before, you should please pause this video now while you try this example. And when you have finished, you can continue the video to see what I have done. So please pause the video now. Okay, so what did you do? Let's read the question first of all. In a random sample of 400 Canadians, researchers found that 133 have taken a vacation in the last year. Construct a 95% interval estimate for all Canadians who have taken a vacation in the last year. So by vacation, I mean international vacation here. Okay, so they've traveled to Mexico or they've traveled to the United States, something like this. So to answer this question, again, we're trying to create a confidence interval. The confidence interval formula looks like so. It's for proportions. And the sample proportion, according to the question, is 133 out of 400, which is 0.33 if you round to 2 decimal places. The complement of that is 0.67, and the confidence level is 95% to give us an area in the tails of 0.025, so 2.5%. The picture you have in mind to find your critical value Z is as shown. And if you look in your table of values, you will see that your Z value for critical value is 1.96. Substituting in your confidence interval formula, you will have, as shown, 0.33 plus 1.96 times the square root of 0.33 times 0.67 divided by 400, which will give you 0.33 plus or minus 0.05. That's your error range. So you get an interval estimate of 0.28 less or equal to P less or equal to 0.38. So between 28% and 38% of Canadians have taken international vacation in the last year. I hope that's clear to you. So that's the end of our lessons for estimating the population mean and population proportion. In the next lesson, I'm going to show you how to figure out what your sample size should be. How big should your sample size be? I'll show you that one in the next lesson.